So, speaking of that, since the goal is obviously to have a continually improving algorithm, how are you like, how do you define and measure I guess you could say losses or the difference in performance? Is that something that every individual company would need to figure out and understand for themselves, or is that something that Continual does automatically?
No, that is something, I mean, so for, so that is something that we have, sort of standard defaults, like smart defaults. Like if you're doing a classification problem, we optimize for accuracy, but, if you wanted to optimize for AUC, ROC, this is where you start to get into the data science terms, right? So or log loss or whatever it is, right? Precision recall. So you have the ability to say, here, what is my performance, performance target? And that again, from our perspective, this is sort of like how many knobs to provide, right? So, but that is fundamentally driven by some business decision, right? Sometimes people care about those things with different weights, and so that would be something that we provide, a standard default. But if you would like to customize your performance metric that we're optimizing for, that would be part of what we would consider a declarative configuration, right? You're saying, here are my inputs, here are my outputs. Here's what I'm trying to optimize for, and then, well, how fresh do I want this model to be, right? So what is the refresh schedules? But from that declarative set of configurations, the system should figure out the best models, operationalize those best models. Yeah.
And do you take into account like because some of these models are going to be predictive, right? So you'll be making decisions based off the model output. That can obviously add some changes in how the input data will look going forward. Is this something that you consider and account for, or is it just like, how do you approach that sort of issue?
Well, just so I understand your question, are you talking about sort of predictions that lead in, like, models that lead into models, or are you talking about, for instance, like when you deploy, an AI system, it actually changes the behavior of the data, and the data is continually, some like recommendation systems, you deploy recommendation systems, people then change their behavior on your platform, for instance. Yeah, just so yeah.
The latter. You deploy like a recommendation system, if people are now getting different recommendations, the input features are going to look different.
Yes.
Yeah.
Yeah, exactly. So, I mean, this is really the heart of Continual. I mean, this is where what we realize is that when you go to production and you're deploying models into production, the world is changing. Part of it's, external factors that are out of your control. And honestly, part of it's the actual machine learning that you're doing and how you're, using that in your tool means that that your behavior of your users is going to change. And you need to then, recognize that. You need to, for instance, obviously see if your input features are changing. You need to see if your predictions are changing, and then you need to see if your performance is changing over time. So, right, often the ground truth, right, what is the actual churn, of customer churn, or what is the actual number of sales? That comes, you make a forecast for sales a week before, then a week later, it, right? You have the predicted and the actual, and you have a true out of sample measure performance at that point, right? You did the prediction and you saw, you probably did your splits when training the model and tried to get an estimate of what your performance would be. But ultimately, kind of the reality confronts you down the road. And so this is just sort of an evidence of why, you fundamentally need to think about AI and ML as a continual system that is being continually maintained. And there's multiple aspects to it. It's not just like the model maintenance process and the prediction maintenance process. It's also the monitoring around the sort of what's going on, what's drifting, right? How's performance drifting? And you kind of need the whole system to have that mindset that that things are, evolving over time, or you end up, and typically people don't think about that on day one. Typically they put a model out there and then they're like, oh man, I probably should have monitoring, and then they do monitoring. And then they say, well, the monitoring is telling me bad things are happening. Okay, I got to have retraining. And then, and then the system gets quite complicated, right? It gets quite complicated when you're building that from scratch. And so, we're trying to build a system that really starts with that, in order to do production, you have to be continual, you have to take into this account. And that does include a lot of this monitoring around what's changing. The nice thing is we kind of have visibility into all of that. We have visibility into the features, we have visibility into the predictions, we have visibility into the ground truth, we have visibility into the models. And so it kind of gives us the ability to like stitch that all together into like a coherent picture of like how this prediction layer is performing over time. And hopefully you don't have to, hopefully just sort of on autopilot, and like if it needs to retrain the model, it does it. But if the upstream data like completely goes haywire, you should get an alert, right? That says like your upstream data is like gone totally haywire. This model is like now it's saying everybody's churning or everybody's not churning. It's clearly wrong. Something is, I would love to fix this for you, but I can't. You, the data scientist or data engineer, need to go up and figure out what's going on with your upstream pipeline, right?
Yeah, that kind of speaks to what my next question was going to be. If there's like a significant discontinuity within the domain, and now situations have changed, for example, there was some sort of global pandemic, and now everyone's purchasing habits are completely different. How would you sort of like, does the model have the ability to account for that in some way? Like, will it start training a new set with the new data and then measuring performance versus each one? Or is that something that you would need to also have like the person maintaining their continual do?
So I think it's the truthful answer, right, is that it's a sort of it's both. So yes, because the model is being refreshed, we are the world is changing. If depending on it, how much data you're looking back to do that training, it's going to start to learn this new pattern very quickly. And the algorithm itself may be able to pick up a change point, sort of a regime shift that happens. And so the algorithm itself, so certainly you need to be retraining and be aware that there's going to be these changes, and the algorithms can pick them up. Now, sometimes you as the human reading the New York Times can recognize that, hey, before all the data's in, I know that the world has changed, right? And at that point, you need to, currently, I mean, you need to basically bring your own expertise to bear, right? And so we think that the analyst and the data team should sort of be in that sort of observational role, where they're spending more of their time just worrying about the data, worrying about that sort of thing. And then when they see something like that, ideally it should be really, really fast for them to think about what the correction should be. Like, hey, we need to stop training on like old data. Maybe we just really need to just use this new data here, because we're not this old data is completely irrelevant, right? So we need to change the training window sample. But in our system, right, that's just changing one query for what we call the model data set. And now now the sort of the world is now we're looking back 30 days versus 90 days, and the whole operational aspect can kind of continue to hum along very, very nicely, right?